Black holes are some of the most fascinating and mysterious phenomena in the universe. These objects are so powerful that not even light can escape their gravitational pull. Have you ever imagined getting close to one of these cosmic monsters? Or even more impressive, traveling to a black hole? What would it take to survive such a journey and face the extreme conditions of space? Let's explore what would be necessary to embark on a survival mission into the vacuum of space and reach one of the greatest enigmas of the universe. Space is a hostile and merciless environment. In the vacuum, where there is no atmosphere, you would face unimaginable conditions. The first essential thing to survive in this environment is a pressurized spacesuit. This suit would be responsible for providing the oxygen needed to breathe, since there is no air in space. In addition, it would need to maintain pressure inside your body, preventing you from being destabilized due to the lack of atmospheric pressure. But the suit is not just for providing oxygen. It would also need to protect you from extreme temperature conditions. In space, under sunlight, temperatures can reach up to 124°C, while in the shade they can drop to -150°C. Believe it, this is one of the greatest challenges an astronaut would face. For you to survive without being burned or frozen, the suit would need extremely advanced thermal control systems, capable of regulating your temperature efficiently and without failure. Furthermore, in space, cosmic radiation is one of the greatest threats to human health. Cosmic rays and energetic particles are everywhere, and our atmosphere, which protects us on Earth, does not exist in space. If you were exposed to radiation without protection, the impact on your body would be devastating. Your suit would need to be designed with special shielding to block or deflect radiation, which would be one of the greatest challenges in terms of space technology. Without it, radiation could cause irreversible health damage, affecting everything from DNA to vital organs. But let's imagine that you manage to overcome these challenges and get close to a black hole. The closest black hole to us is thousands of light years away. To reach it, it would be necessary to travel at speeds close to that of light. Currently, our fastest spacecraft would take thousands of years to reach a black hole. This means that the technology required to get to a black hole is far beyond our current capability. However, physics is always advancing, and new discoveries may arise to enable faster travel. As you approach a black hole, gravity would begin to become unbearable. What would happen? The gravity of a black hole is so intense that it begins to distort space and time around it. You would begin to feel a strange sensation as you approach the event horizon, the point of no return of a black hole. To those far away, you would appear to slow down as you approach this region. However, for you, time would continue normally, but the effects of gravity would become increasingly extreme. As you approach the event horizon, time and space around you would begin to behave in a completely different way. According to Einstein's theory of relativity, the gravity of a black hole is so intense that it distorts space-time itself. For someone traveling in the spacecraft, time would continue in the same way, but for outside observers, you would appear to slow down as you moved closer to the black hole. As you cross the event horizon, time for you and for the rest of the universe would be distorted in an incomprehensible way. This phenomenon is called time dilation, and it is one of the most surprising effects of a black hole. The intense gravity would affect everything around you, including light, making the events happening inside a black hole invisible to us. This leads us to one of the most intriguing questions: what happens inside a black hole after crossing the event horizon? Science still has no definitive answer. Most scientists believe that once you cross this point of no return, you would be pulled toward the center of the black hole, where gravity is so strong that there is no longer any possibility of escape. This region is called the singularity. In the singularity, the curvature of space-time becomes infinite, and the laws of physics as we know them cease to function in ways we can understand. Theory suggests that anything entering a black hole, whether light or matter, would be crushed and destroyed, with no possibility of escape. If you were physically able to cross the event horizon, you would experience what scientists call spaghettification. This is an effect caused by the immense difference in gravitational forces between the upper and lower parts of an object. This means that, as you approach the singularity, your body would be stretched outward like a strand of spaghetti, until it disintegrated. For a human being, this experience would be fatal. But the most fascinating part of all this is the fact that physics still cannot fully explain what happens beyond the event horizon. Some theories, such as string theory, suggest that the black hole could act as a kind of portal to other dimensions, or even to other parts of the universe. The idea that a black hole might be a kind of bridge to another universe or another region of space is one of the most intriguing in modern physics. Even so, current technology does not allow us to make such journeys. We do not have the resources necessary to withstand the extreme forces of a black hole. And even if we managed to travel at a speed close to that of light, it would take centuries or more to reach one of these objects. And even if we got there, the conditions would be so extreme that survival would be impossible, at least with today's technology. However, scientists do not give up on understanding the workings of black holes. The search for answers about what happens inside these cosmic objects remains one of the greatest missions of astronomy and physics. Each new discovery takes us one step closer to unraveling this mystery, and who knows, in the future technology may allow us to explore black holes more safely and better understand what happens when one crosses the event horizon. As scientists continue to study black holes, new theories are being formulated. One of the main challenges for researchers is the attempt to combine Einstein's theory of general relativity with quantum mechanics. While relativity accurately explains the behavior of large scales, such as the gravity of a black hole, quantum mechanics describes the interactions of subatomic particles. However, these two theories have not yet been fully unified. Black holes, with their extreme conditions, are the perfect laboratory for this combination, but full understanding is still far from being achieved. Recently, new ideas have emerged about how the interior of a black hole may be structured. An interesting theory is that of the white hole, which suggests that at some point the matter falling into a black hole could be expelled back into the universe. Imagine that instead of being destroyed, matter could be transported to another point in space-time, creating a connection between black holes and white holes. This concept is still highly speculative, but it opens up a range of possibilities for understanding the behavior of space and time. Another concept that has been gaining popularity is that of lost information. According to quantum physics, the information about matter that enters a black hole would not be lost, but rather stored in some way, perhaps on a peculiar surface called the event horizon. This theory, called the information paradox, seeks to answer a fundamental question. If matter is destroyed inside a black hole, how can we explain the fact that the information about that matter still exists in the universe? Solving this issue could lead to a new understanding of the nature of space-time. If this theory is confirmed, it would change everything we know about black holes. But for now, all we can do is observe the effects of black holes on their environment, such as the way they affect stars and gas around them. By observing how black holes interact with other celestial bodies, scientists can better understand how the extreme gravity of these objects affects space-time, as well as attempt to resolve fundamental questions about physics. There is still much to be done before we reach a full understanding of black holes, but the most recent discoveries bring hope that one day we will be able to decipher these enigmas. Direct observation of black holes is already becoming possible with the use of advanced telescopes, such as the Event Horizon Telescope, which managed to capture the first image of a black hole in 2019. This marks a great victory for science and a huge hope for future discoveries. The next big step is to try to unravel the mystery of the interior of black holes. With more research and new experiments, it may be that one day we will be able to explore these inaccessible regions and, who knows, understand the true nature of the universe. Until then, black holes remain one of the greatest mysteries in physics, and our search for answers continues. We have now reached the point where possibilities begin to expand even further. Imagine for a moment that humanity has the resources needed to send a spacecraft to a black hole. How could such a mission be possible? What would be necessary to send a team to explore one of the greatest mysteries of the universe, knowing that any mistake could be fatal? First of all, beyond the spacecraft and the advanced spacesuits we have already discussed, it would be essential to ensure that astronauts had a reliable communication system with Earth, even across immeasurable distances. How can contact with travelers be maintained while they cross such an intense gravitational field? In addition, the conditions inside the spacecraft would need to be strictly controlled. Remember that cosmic radiation is one of the greatest threats in space, but when approaching a black hole, this radiation would increase drastically. To protect the crew, an advanced shielding system would be necessary to block this intense radiation, ensuring that the crew would not suffer irreparable damage. Without this protection, even the most powerful spacecraft and the most sophisticated suits might not be enough to guarantee survival. And what about navigation technology? To navigate toward a black hole, the spacecraft would need extremely fast propulsion systems, perhaps even using concepts such as antimatter propulsion or other still unknown forms of propulsion. These systems would allow the spacecraft to reach a speed close to that of light, making it possible to travel to the black hole in a shorter time than would be possible with current spacecraft. But the journey would not be simple. The spacecraft would need to constantly adjust itself to deal with the gravitational effects that distort space-time, adjusting its trajectory as it approached the event horizon. Now, let's imagine the situation of a successful mission. You have reached a black hole. What happens after observing these fascinating phenomena up close? One of the biggest dilemmas would be how to collect data efficiently, knowing that as you approach the event horizon, radio waves and other signals could be distorted and even lost due to the intense gravity. This is the kind of challenge that science still needs to solve so that we can truly explore these cosmic monsters. The future of black hole exploration is uncertain, but the possibilities for new discoveries are endless. If one day we manage to explore these cosmic phenomena more deeply, we may understand how the universe works at its most fundamental level. The discovery of new aspects of physics which may arise from these studies could redefine everything we know about space-time and perhaps even open doors to the exploration of other dimensions or realities. And you, What do you think about all this? What do you think exists beyond the event horizon of a black hole? And if you enjoyed this content about the mysteries of the universe, don't forget to subscribe to the channel so you don't miss anything.